about IoT security.
Thank you very much. Thank you, everybody. So I'm going to talk a little bit about IoT. I'm also going to talk about connected cars, and I'm also going to talk about Kayla. Before we get going now, just a little... Let's do that. So a little bit about who we are. We're pen testers, but ultimately in our spare time we like to kind of break into stuff like IoT and cars. And ultimately when you hack into an IoT device, the reality is that the worst thing that's going to happen in most cases, up until a couple of weeks ago, was that you were going to get Wi-Fi credentials off there and you could potentially hack into the home network. Nowadays we're looking at DDoS and potentially other attacks, but certainly when we look at a car attack, the sort of vulnerabilities or sort of the impact from hacking a car, far-reaching. There's lots of scary things that can happen once you hack into real cars. But when we look at IoT, what's the main issue? Well, the main issue with manufacturers of IoT devices is that there's so much to look at. So, when you build a website, you just need to build the security into that web application. When you build a smart device, smart product, whatever it is, you need to look at the mobile app. You need to look at API. You need to look at your web apps, whatever you've built for that service to interact with. But not only that, you've also got Wi-Fi, Bluetooth, any other I/O connections. You've got firmware. You've got the actual device the thing's running on as well. You've got to consider security for. So in terms of building these systems, there's so many areas for vulnerabilities. And if we just take this kettle, for example. So a Wi-Fi kettle. Kettle is something which we have to have in every British home, as you would expect. Hopefully you've got a few in your houses, but most people in Britain will have a kettle. You don't have to have a Wi-Fi kettle, though. Most people have got a normal kettle. The Wi-Fi kettle that we've got on the screen there, that comes with a mobile application that allows you to boil it from your smartphone. A little bit pointless, I have to say. It saves you about 60 seconds, but it costs you about 100 euros more for the Wi-Fi capability of the kettle. It's really rubbish as well. They break constantly, so you spend a lot of money on this rubbish device and then it breaks. The biggest issue, though, really is that you stand outside the house with a strong wireless antenna, point it at the kettle, send it a deauth packet, and then suddenly the kettle will deauth from the home network. You can then authenticate to the kettle using Telnet. Really? Telnet to a kettle, it's bonkers. Once you telnet to the kettle, you then simply ask the kettle to give you the credentials for the Wi-Fi home network. That's not ideal, right? Because then, of course, you can hack into the home network. So, obviously, we put it to the vendor and we said, all right, what are you going to do about it? And the vendor's response was like most IoT vendors. They said, well, it's not really an issue. It's a very technical attack, and actually, you're going to be hard-pressed to find someone with one of these kettles. Now, I don't think that's an indication of their business model. I think it's more of a case that, a kettle lives in someone's house, right? So it lives inside their kitchen. It's not like it advertises itself on the street, does it? Well, it kind of does. There's a few in London. So what happens when the kettle ships? It ships with a default access point, an ad hoc network for you to connect up to configure the Wi-Fi, and that's called iKettle. Has anyone heard of Wiggle.net? Wiggle is an open-source war-driving database of access points. Search on wiggle.net for iKettle. You'll find a number of kettles within the UK and around the world that you can then just immediately go and connect into. Not ideal at all. Now I want to talk about Kayla. So this is my friend Kayla. She's not quite as clever as Robbie, I have to say, but she's still quite cool. She's an interactive doll that your child can talk to. She is basically Bluetooth. She is basically a Bluetooth headset, so you could kind of stick her next to your head and drive down a road. What you would get arrested for, I'm not entirely sure, but certainly you would probably be arrested. But it's got a little application, which I've got on my little tablet here. So it's got this little companion app here, and effectively the application allows your child to talk to the doll. She's always listening. She never stops listening, but she never talks to me, which is quite funny. It's a bit like my wife, really. I'm joking. Of course she does. And the thing is, she's got voice recognition, nowhere near as good as some of the other devices. So certainly Robbie, for example, she's nowhere near as good as that, and certainly nowhere near as good as Siri. But she does have very careful control over what she can and can't say. So, she can't swear, for example, because, you wouldn't really want a doll swearing at your child, would you? But obviously, like all hackers, we kind of wanted to know if we could make her swear. And, well, the answer is it's quite simple. And so the way it works is to do with the device. So on the Bluetooth side of it, there's very little in terms of authentication. But then there's an application on an Android device, and the problem is developers just don't realize that you can actually do quite a lot once you hack Android applications. You know, it's really easy to hack Android applications. And to demonstrate it, what I'm actually going to do is I'm going to get Kayla to read this part of the presentation. So hopefully this mic will work, and hopefully she'll hear it. Can you hear that? She's very quiet, but the TV can hear it, but none of you can.
I love to tell stories. This is a great one. So how did I get hacked? Well, it works in a number of ways. Firstly, because I have a database of questions a child can ask me, and I will provide a canned answer. I am not allowed to swear, though, and so I have a database of bad words. Both can be modified. I also can look up things from Wikipedia. This can be intercepted and modified. However, the easiest way is to modify this story I'm reading now, and then I can say anything I like, including swear words. Myself and Robbie are going to get drunk on Black Balsam on Old Town.
So you could just about make out that she's going and getting drunk with Robbie, which would be quite cool. And to be honest, I think she'd probably be the instigator, because she is absolutely terrible. So, you know, obviously there's that database of bad words that you can hack into. The Wikipedia, interestingly with Wikipedia, she used to just use HTTP for Wikipedia, and then Wikipedia changed to HTTPS, and then it doesn't work anymore, which is quite amusing, but anyway. So obviously we contacted the vendor, we asked them to fix it, they completely ignored us, the other way, they completely ignored us, but then they decided to update the app, and they decided to update the app by encrypting her bad word database, and then stuck the password in the actual app. Which is not really that sensible, to be honest. So, you know, that's kind of toys and the kind of IoT that's less dangerous. When we look at hacking cars, it's a lot different. So hacking cars, for example, the attack surface is even larger. There is so many different ways to hack a car. If we look at the Jeep hack, for example, that used GSM and the infotainment system and the way that it was bridged to the CAN, so effectively from the GSM network, you could bridge directly to the CAN and control the car. The Nissan Leaf hack that Scott Helm and Troy Hunt did, that was just using the web API that had been created so that people could modify the infotainment system through their phone. And then there's the Tesla hack. There's been a couple of Tesla hacks. Essentially, both of them have the same raw vulnerability, that there's poor separation, or there has been poor separation and poor trust relationships on that device. But we wanted to have a look at the Outlander. So the Mitsubishi Outlander is a really interesting car. I don't know if anyone's got one, but they've created this plug-in electric hybrid vehicle. And essentially, rather than having a GSM network that the car talks up to an API server, or to a server, and then your phone talks to the server, what they've got is they've just decided to do it in a really cheap way and stick a Wi-Fi access point on the car. So you connect your phone to the access point on the car, which is a bit rubbish, I have to say. And actually, you know, it's very cheap as well, and doesn't do a very good job. You know, one of the features of the app is that you're able to find the car, except the wireless network only extends about 10 meters. So if you're really blind, you might be able to find your car. Contained within the manual is the PSK and the SSID for the Wi-Fi account. Now the thing is, you can change the SSID, but you can't change the password. And when we look at the format of it, the SSID is effectively remote, 2 numbers, 4 letters. The password, just simply 4 letters and 6 numbers. And that is just not good enough. You know, we've got a really tiny cracking rig of about 4 GPUs. We can crack that in about 2.5 days. This one up here, which is an ex-Bitcoin mining thing from Russia, you know, that would do it in a very, very short space of time. If we look at Amazon Cloud Compute, it'll cost us about $1,000, but we'd be able to, or £1,000, it would be able to crack that almost instantly. So, you know, that type of key is just not good enough. Once you've cracked it, you can then gain access to the communication. And so essentially, the bits on the screen there, the red bit is the bit that goes to the car. The blue bit is the bit that comes back from the car. So we've kind of snapped it somewhere in the middle there. But essentially, anything beginning with F6 is a message that's sent from your phone to the car. So once you can kind of understand how the communication works, you can do things like turning the lights on. And I'm hoping this video will work, just like that, right? So that's the command. You send that command to the car, and then you can turn the lights on. That's not so much of an issue, is it really? What's more of an issue is if you turn off the alarm. And so if we send that code, and I'm going to pass over to my colleague Ken to speak now.
It's not going off. Even worse, I'm now in the car.
So we can unlock the car remotely from the phone just by cracking the Wi-Fi passcode. And of course then, once we're in the car, you've got access to the ODB2 port, and you can start to use that to create new keys and then drive off in the car. I mean, it's a keyless car, keyless driving. You don't need to shove a physical key in the car to drive it. You just need to have the right coded key. Not ideal at all. So that's kind of stealing from a car, or stealing the actual car. But what about other attacks we could do with the car? How else could we make money with the car? Now, this is kind of sort of moving further into the theoretical approaches of hacking cars and hacking in general. We've all kind of seen ransomware, right? Hopefully none of you have had it on your computer systems. Hopefully none of you developed ransomware. That would be really bad. I couldn't possibly recommend that. But this one here, this is obviously CryptoLocker. Now, obviously, if you've ever had CryptoLocker installed on your computer, you'll know it's a right pain to get rid of. The reality is your data's probably lost. So, would you pay the ransom? Well, pose the question, well, what happens if it's got pictures of your children on the device, on your computer? You've not backed them up. You have no backup. And it's, from your child from 0 right the way up to 10, perhaps. You're never going to get those pictures back. You can't get them back. So that's a bit of a risk. Or perhaps, what happens if it's a work computer and you've got loads and loads of work on there, and the only way to get it back because your backup doesn't work is to pay the ransom? Would you be prepared to pay it? Well, we know that people are. But what about this scenario? Imagine that it's very cold at home, -5, something like that, something I guess you guys are probably quite used to because you're quite far north. And, it's really, really cold. Suddenly your children wake up in the middle of the night and they turn around to you and they say, "We're really cold, Dad, put the heating on." And then suddenly you're faced with that. So what are you going to do? Would you pay that ransom? Well, I'd suggest that a lot of people probably would. So I've actually got it here. I've got the device with the ransomware on. And so effectively, it's a common thermostat from America. So we actually this is genuine, we actually put ransomware on this thermostat. So it's a common thermostat from America. It's ARM-based. We looked on FCC to determine that. It's also got Linux. So it basically runs Linux, which is quite cool. So it's a little Linux device. It's got some firmware updates you can apply to it, and I'll talk about those in a second. We felt, looking at the device, we were fairly confident we'd be able to get root access to it. And if we can get root access to it, we can then start making modifications. So we had a look, and interestingly, also, it's got an SD card and a Wi-Fi port. So it essentially has got its own wireless client, so it can talk directly to Wi-Fi. The SD card is for updating the firmware. So there's a really nice, simple ways of attacking into the device. And unfortunately for this particular manufacturer, end users demanded the ability to set a wallpaper on their thermostat. Really? Is it such a big deal? Why would I need a wallpaper on my thermostat? Anyway, but because of that, they created this whole PC-based application where you can update things like your images on the device. You can also update the firmware on the device, and because of that, the firmware is embedded within that application. So it's very simple to just extract that out, use binwalk to view the firmware, and as soon as you can view the firmware, you can see all the file system, and then we found that we can access lots and lots of different binaries on there. When we reviewed the actual file system, what we found is that the entire application runs from a very large JavaScript file on the device. And like most people who develop these sort of things, they didn't think that someone might be able to modify that. And so they allow end users to upload images to the device, but what they didn't realize is that people might want to do malicious things to that particular JavaScript file. And so they didn't put any file validation in or input validation. So end users can input their own code in with the application, and that's essentially what we did. So as soon as we can do that, we then injected much more complex commands, such as putting telnet on there so we can get remote access to it, such as altering configuration of the device. And it's all because the file name was not trusted, or was trusted. You know, the file input was trusted. And so when we came to the ransomware, so we've actually got that access now. The next things are to, you know, simply stick a screensaver warning on there, and you can see it's got there on there. So if you tap the screen, it then says, look, you need to unlock it. And it's got a passcode. You press unlock, and, you know, obviously as an end user, you're not going to know what that passcode is. And of course, we'd make sure the system changes it regularly, so, you know, you couldn't guess it. I think it's 4 characters, so there's only 10,000 combinations, but, you know, at the end of the day, it's going to be a bit of a pain when your kids are stood in front of you saying, we're really cold, can you put the heating on? Yes, you can put an annoying buzzer on there, but what's really, really cool is you can also use that for air conditioning. So when it's really, really cold, obviously as nasty, malicious attackers, we'd turn the cooling on, wouldn't we? We'd make it maximum cold, so it's even colder in the house. Or when it was really, really hot, we'd turn the temperature up, so it is really, really hot in the house, and obviously make you want to pay the money. And that's really it. You'd have to throw it away or pay the ransom. That's really all you could do with it. You know, it's about $200, this particular device, so it's not hugely expensive, but it's not something you're going to be able to do in the middle of the night when your children are in front of you screaming at you to turn the heating on. And so, you know, that's, yeah, ransomware on your device, on your thermostat in your house is a bit of a problem. Yeah, you know, it's annoying. You can leave the house, though, ultimately. Go around to a family house, for example. What happens if you get into your car and suddenly, you know, you're late for a meeting, or your children are desperate to go to school, which is quite unusual, but anyway, if they were desperate to go to school, and suddenly they're saying, take me to school, or your wife is away, or your partner is away, and suddenly you get into the car and you're faced with that. What are you going to do? What options have you got? Hire a car, take a taxi, yeah, you could do that, or pay the ransom. And we know that people pay the ransom from CryptoLocker, so would people pay the ransom on a car? Quite possibly. And that's kind of, you know, that's kind of like one car, but what about if one morning every car stopped working, or every model of car? So if a manufacturer releases a connected car, I don't know, like the Outlander, for example, or perhaps one of the ones which has got a better connectivity to the cloud, and then suddenly every single model of car stops working. Maybe the Prius, the Toyota Prius. Why the Prius? Well, because the Prius is used by government ministers in the UK. So if you stop the Prius working, then you kind of stop governments working. Could that happen? Possibly. What happens if it's an ambulance? What happens if it's the fire trucks? What happens if it's the police? You stop every single one of those cars working and then set off a bomb. It's going to cause chaos, absolute chaos. Do we think this is a likely scenario? I think probably not tomorrow, for sure. I think certainly, potentially in the future, we could see something like that if manufacturers aren't looking to secure their systems appropriately. One of the ways they can do that is by talking to security researchers. You know, security researchers, we're usually well-intentioned. And usually, we just want to make things right. Most of the time when we're looking at cars as well, we're usually doing it on our own cars. We're not getting a car and then sending it back. We're doing it on our own car that we've bought that we want to drive. So, you know, we have a vested interest in making sure the security is good. And so if you are a manufacturer of one of these or an IoT device, you know, what I'd recommend is engage with the security community. Tell them how you want to be communicated about security vulnerabilities they discover. Set terms on what is acceptable and what is not. And, you know, offer them credit. One of the ways to do that is with bug bounties. You know, bug bounties, yeah, they've got their flaws, but actually they have also got their benefits. It's a relatively cost-effective way of engaging with the security community and giving people kudos. You know, the other option, of course, if you are a manufacturer of a car, is to give them a car to play with, which I know sounds a little bit far-fetched, but actually, you know, manufacturers make millions of cars a year. You know, one car is not massively expensive to them to give away. So I thought what I'd do is I would have a look at car manufacturers' bug bounties to see what's out there. And as you can probably guess, Tesla are kind of the best in this field at the moment. So Tesla currently offer $10,000 for the maximum they will offer for full remote compromise of a Tesla, or perhaps all of their Teslas. Really? $10,000? That's all it's worth? I find that shocking, don't you? When you think that, you know, the impact to both their reputation and potentially to people's lives, you know, we've already seen autopilot and the accidents that it's had. You know, really? I think that's not enough, in my opinion. But then you think, well, Fiat Chrysler, $1,500 is the most they will pay. Really? That's all they care about, $1,500. They're not the worst, though. The worst, the GM, they just won't sue you. Great. Well, that's really nice to know. If we look at Ford, they don't do anything. They just said they monitor the security situation. All right, fair enough. Yeah, good work. And then anybody else? No, nothing. No one does anything. They haven't even commented on it. And yet they're rolling out all these connected cars. And so, you know, what I would suggest is, you know, let's get connected car security right before we start thinking about autonomous vehicles. And, you know, even Tesla, who are brilliant, actually, to be fair, at sorting out the systems, the biggest benefit they've got is remote updatability. A lot of cars don't have that capability at the moment. You have to come back to fix them. And when you think about the lifespan of a car, it's 16 years plus. I was at an auto conference the other day, and I found that out. Initially, I thought it was only about 10 years, but actually, manufacturers build cars for about 16 plus years, which is crazy. Can you think of the supported model? Look at Nest, for example. Nest, when Google bought them, they had their very version 1 of the Nest thermostat. After 4 years, they stopped supporting it. You can't do that with a car. You know, after 4 years, that Nest device doesn't work. You have to throw it away. Your thermostat in your house, for example, is probably as old as your house. So, you know, you're looking at, what, 20, 30, 40 years, maybe longer? Google are creating a Nest device to last 4 years. Well, a car, you just simply cannot do that. And so, you know, with an unconnected car, manufacturers can support it for longer because the biggest risk really is going to be theft of the actual vehicle or theft from the vehicle. Or perhaps crashing because they've made a problem, or maybe a fuel emissions, but, you know, that's not a security issue. With a connected car, you know, it's much, much more deadly. Anything is possible, really, when we start talking about connected cars. So on the IoT side of it, you know, attacking IoT, there's a lot of really, really good knowledge out there. But the basic principles apply. Least privilege, least functionality, and encrypt your communications and your backup and your firmware updates. And if you have got outsourced developed shops doing the work for you, look at their policies, look at their processes, and really review what they're actually doing and really specify security in the contract. But, you know, the bottom line is, you know, with all of that and with all of the risks that we're seeing in IoT and all of the risks we're seeing in connected cars, are we really ready for autonomous vehicles? I'm not so sure we are. Thank you.
Thank you very much, Tony. Thank you.
Thank you.
And
Right, look at that.
yeah, that's a secret gift from the organizer there. We do have quite some time for questions. I'm sure we will have some, right?
Yep.
I'm going to give you the mic so people on the internet can hear us.
What's your estimate? Has anyone died already from impact of hacked IoT device?
I don't know if they have, actually. I'm not entirely sure that I know, to be honest. No, I don't think so at this stage. But, you know, we look at autopilot on the Tesla, but there has actually been deaths with autopilot, as, you know, it's probably well publicized. But, you know, in terms of your thermostat getting ransomware on it, I don't think there has been deaths from that. And certainly your kettle, someone getting your Wi-Fi, that's probably unlikely to happen. But, you know, the theory is that we think it's there. And the other thing that I didn't talk about, which the other real risk that I didn't talk about, which we do think is very much a real risk, is around the whole concept of power. You know, the DDoS that we've seen, the Mirai botnet, is rubbish, actually, really rubbish, because the botnet just uses telnet and SSH. Most IoT doesn't use that. Most IoT uses web services. So if that was configured to use web services, then the impact or the devices they could access could be far, far greater. And the other thing is, when you start doing that, could we see a situation where hackers are able to target all of the IoT devices through their web services and get them to perform an action at exactly the same millisecond at the point when the national grid is at its maximum capacity? What's going to happen? The grid's going to overload, it's going to shut down, and what happens in that situation is effectively we have a massive power cut, and then we potentially might have to go back to a situation called a black start, where effectively you have to start up the power generators with a tiny little generator in the power station, which then starts another generator, which then starts another one, and another one, and another one, before you eventually get to the one which actually makes the electricity. We see that as a very viable attack. But attackers haven't kind of thought about that, unfortunately, because that really could end up with lives being lost. Power cut for sort of a week or so, which is probably what it would take to recover, could see some very serious implications for people.
Thank you very much for your extended answer. We have next question here in the back.
Hi. Speaking of killing people, since huge companies...
Why does everyone want to kill everybody here? Really?
Since like huge corporations, they produce stuff for civil and military. Do you have any statistics of military equipment being hijacked or blocked by ransomware?
No, I don't, unfortunately. No, we haven't been asked to do any testing on IoT in military environments. We'd like to. If anyone wants to get us to have a look, that would be really cool. But most of the IoT stuff we look at is stuff that you can actually buy off the shelf, so to speak. And it's very hard to walk up to an arms supplier and say, we'd like to have access to your latest gun, please, so that we can test it for security vulnerabilities. Honestly, we won't kill anybody. It's quite hard to do that. So, we get Kayla, for example. So yes, potentially that issue does exist. I would really hope that they have been effectively tested. But certainly not by us at this stage. But if anyone would like us to look at that sort of systems, then do come talk to me later.
Well, I do suggest you do try and approach some weapons manufacturer with that line. It might work. We do have time for the final question, if there is any. Okay, if not, another warm round of applause here for a speaker here. Here's your certificate.
My certificate. Thank you so much.